Hey everybody, I wanted to go over just a couple of problems in terms of using matrices to solve a system of equations. So here we have a system that looks like this. We have 2x plus 8y equals 7 and 3x minus 5y equals 4. And so let's do it, sort of the old-fashioned way, and let's use elimination. No matrices, just start. Let's use elimination. And let's eliminate x. So that's the one where you're trying to multiply each of these lines by something so that we get these two coefficients on x that are going to go away. So we see 2x on the first equation and 3x, and we'd like them optimally to be the same but opposite. And so we can do that by taking this whole line, multiplying it by -3, and then taking this whole line and multiplying it by just +2. Now, if you're looking at this and thinking, why couldn't I eliminate y? You absolutely could, but to have this match up with row echelon form, which is what we're going to do with matrices when we do this all with a matrix, or a system or a set of matrices, we're going to want to eliminate x, because that's just going to more neatly conform to the structure we're going for, and that's it. So, I had said we're going to multiply this first thing by -3, right? Okay, there we go, -3. And so this first line becomes -6x, and I'm not even going to have this thing here. We're just going to do -6x plus 8y. Nope, that's not right. -6x minus 24y. Sorry, I'm thinking about too many things at once. Minus 24y equals -21. And then, meanwhile, by multiplying the second line by 2, we'll get 6x minus 10y equals 8. Okay, maybe not the greatest thing in the world, but that's fine. We can make this work. So we're going to add these two lines together. So that's what elimination really is adding two lines of your system to one another. -6x and 6x go to 0. -24y and -10y add up to -34y, and -21 and 8 add up to -13, so y is just 13/34. But we're not even going to do that. I'm actually going to undo that. Don't write that down just yet. So what we would then take a look at is what we have in here is the system. We could write either the first equation or the second one, but let's just write the first one first. 2x plus 8y equals 7. And we also have, -34y equals -13. Now, both of these are pretty gross. I don't like the way they look because they have coefficients on the leading term that isn't 1, or that aren't 1. And so we're going to just take this whole first line, multiply it by 1/2, and take this whole second line and multiply it by -1/34, which, okay, great. That's -1/34 is no one's cup of tea, but it's going to work out just fine. So we're going to end up with x plus 4y equals 7/2, and just y equals 13/34. Okay, 13/34. It's a pain, but we can handle it. It's just a fraction. You just got to go slow. And so we would say, all right, x plus 4 times 13/34 is equal to 7/2. And now we're just solving. So we're saying, okay, x plus 42/34, I'll simplify that in a second, is equal to 7/2. X plus 21/17 is equal to 7/2. Actually, I probably should have left it with the 34ths. All right, x equals 7/2 minus 21/7. And this gets us x equals, let's see, 17 times 7 is 49 plus 100, and, oh boy. Times 7, 9, 49, 119/34. Minus, what was 42? Sorry, that's 17. 42/34. And so we're all left with x equals, I should have picked a simpler problem, 77/34. Okay, so we've done this without a matrix. So that's a decent start. And if it's a two variable equation, there's not a ton of reason to use matrices at this point in our math careers, but we can do it anyway. So we're gonna look at this original problem. We're gonna say, okay, I had 2x plus 8y equals 7. So I'm gonna say 2, 8, 7 will be my first row, and 3x minus 5y equals 4. So we're gonna do 3 minus 5 and 4. So this is going to be the augmented matrix that we are going to use to solve this equation. And what we are trying to do is we're going to try to do some what we call elementary row operations that put a 0 right here in this bottom left spot. Okay? And the logic that we're doing is exactly the same that we just did when we were solving, or when we were doing it with the variables all written down. So we're going to keep this first row the same. We're going to keep it as 2, 8, and 7. And what we're going to then do for the second row is we're going to take 2 times the first row. Sorry, take it back. Negative 3 times the first row. So negative 3 times row 1 plus 2 times row 2. And when I'm referring to row 1 and row 2, those are the row 1 and row 2 of this matrix that was preceding the one we're currently working on. Okay, so we're going to enter all of these points slowly. So we're going to have negative 3 times this value of row 1. So negative 3 times 2 plus 2 times 3. So that's going to be negative 6 plus 6. And so we do get this 0 that we wanted here. Now, of course, we picked the operations, the row operations, we picked this thing so that we would get it there. So it's not surprising. And if you're thinking, well, like, why does it turn out that way? It turns out that way because we chose to do it. We did it on purpose. And then we take a look at, all right, I have to do negative 3 times that. So negative 3 times 8. I'm even going to write this one down. So negative 3 times 8 plus 2 times negative 5. So 2 times negative 5. That's negative 24 plus negative 10. That's negative 34. And so in this next entry, we do get negative 34. I was kind of hoping that I had screwed up at some point and that the numbers weren't this gross, but it seems like they are, in fact, this gross. And so lastly, we're going to say, all right, I'm going to take negative 3 times this one. So that's going to be negative 21 plus 2 times 4. So that's going to be 8. So I'll write this out here. So negative 3 times 7 plus 2 times 4. So that's negative 21 plus 8. Well, that's negative 13. And so we plug in the negative 13 in that final spot. Okay. So the beauty of this is we are really close to being in what we call row echelon form. We just need to fix up one thing. So we have these two values here. If this is going to be an row echelon form, they both need to be 1. So what can we do to make that happen? We're going to take this matrix and we're just going to say, all right, row 1 is going to get 1/2 of the previous row 1. And so I've been using this notation of 1/2 row 1 is what's becoming the new row 1. So I know that arrow notation was a little tough maybe, but we're going to get 1, 4, and 7/2. And then for this one, we're going to get negative 1/34 of row 2 is going to become our new row 2. Okay? So it's not an equal sign. It's what is going to become that thing. And so we would get 0, and then we get a 1 there, because I needed to multiply row 2 by something so that this term in the second column would become 1. Well, negative 1/34 will do it, and that becomes 13/34. So it looks like we did, in fact, do this correctly, which is so upsetting because these numbers are so gross. And what we get here is just this final set of equations. Once it is in row echelon form, let's write out the equations again. And so we're going to get this first equation, which is going to be x plus 4y is equal to 7/2. And the second one, which is just y is equal to 13/34. Those were the exact equations we had when we did it with all the variables. And the nice thing is, I trust all of your ability to take this answer, plug it in for y, and evaluate. Plus, we just did it. Okay, so that's with 2. In the next video I'm going to make, we're going to do it with 3 variables, but it's all going to be the same logical steps. It's just more steps because it's more variables. Okay, hope this helps.